Today, the ds-incubator is going to be covering test-driven development, which is mentioned in the subsection philosophy of the testing chapter in the book Mastering Shiny. It is this style of writing code where you actually first write a failing test that checks for the property that you would like your feature to include, and only then you write the code. And the code that you write is the minimum amount of code that makes that test to pass. And then the next stage is to use basically safety that you built for yourself with tests to then aggressively refactor your code to make it cleaner, to make it easier to read. So I'm going to be moving super fast today. It's just to kind of demonstrate how the workflow goes. It is like going to watch a tennis match. I'm not expecting you to learn a lot and become a professional tennis player by watching other people play. This is the kind of thing that you only really learn once you practice a lot. But also I wanted to show test-driven development early in the series of meetups because there's nothing special about it other than changing the order in which you test and build code. So I do, the speed might be a little bit intimidating, but the approach itself should be quite accessible to everyone. In terms of requirements, last meetup, we cover basically the basics of workflow of testing, and you're going to be seeing this today in action. So while you may not hear today why we do what we do, what I do, but at least you will see everything that we have covered before, just that implemented as opposed to kind of discussing it. So the very first thing you do when you start, in this case, I'm going to be working a lot with DevTools and functions that come in DevTools with the package use this and also test that, right? So all those things you could normally attach them with library, like something like library test that, but usually I don't need to do that because I have configured my R profile to do that for me every time I restart my session. So that's what I could do right now, restart my session. And the first thing, in test-driven development that you do is you use the function use test to create a test file with the name of the function that you want to develop. So this is the name of the function I want to develop, load file. This opens a test file. Actually, it includes some demo code, which I'm gonna delete. Instead, I'm gonna write my own. The three things I would like this feature to do is, one, I would like load file to be able to read a CSV file. I would like it to read a TSV file, and three, I would like it to error gracefully if the file given has an extension that is unknown, that is not CSV and not TSV. So, okay, that's the formulation of my test. So I'm going to be using one of the two most important expectations in test that, which is expect error. In the actual meetup, CJ asked about, which test you would write first, if, the test that checks for the property about the error, or if you write first the test that checks for the property about TSVs or CSVs. It is probably more natural to start writing the test for the main thing that the function should do, something like, okay, it reads a TSV file or CSV file. But I'm going to start with the error because it's super easy to implement, and that will give me some momentum, basically. I want to show very quickly a first iteration of test-driven development, and this will allow me to do that. So expect error takes two arguments, argument 1 and argument 2. So in argument 1, you basically it's called object. So you call the function that you want to test, and here I'm gonna be using let's call it file dot. Oh, actually, let's get blah. So blah is something that should throw an error. An error I would like to see should read something like let's say invalid file, I think, for example. So let's do that. So that's my test, but if I run that test, I'm pressing Shift Control T, that's part of the workflow. that test, should fail, of course, but the reason why it should fail is because the function load file is not yet implemented, which is fair enough. So let's go ahead and implement it. So I'm going to use R, which is another function that uses this package. And I'm not going to use any argument because I have opened already the test file that corresponds to that code file, and use R and knows about the active document, so automatically can generate a file in R that will contain the code, the implementation of load file. So let's write that implementation is a function. Let's give it an argument called file, and because load file is files, and let's start by doing nothing. Let's see what that happens. So if I run my test again with Shift-Control-T and save the file, I still get an error, but it's not the error that I wanted, because it throws nothing, right? So if you implement the function with nothing, that function returns null. So it does not throw an error. So what we need to do is to actually implement that error. Let's do stop invalid file. So that is the first thing that my function does. So I implemented the error. The error is graceful. It says invalid file. And I have just effectively finished the first iteration of test-driven development. I wrote the test, then that fails. Then I wrote an implementation and the test passes. And then the third bit of it is to refactor the code now that I have the safety of the test. But there's nothing I would refactor here. I think it's pretty okay as it is. So let's go through, let's move on to test another property of the function, maybe the most interesting one that can read a CSV file, for example. This is it's going to be a little bit of work because we need a CSV file. So to create a CSV file, I'm going to first create a data frame. I'm going to do it with the function table. Small data frame would be x equals 1, y equals 2, for example. So I can show you what that data frame looks like. There it is. And now we need we need to store in a file. So the file, let's call it file, and I'm going to use a temporary file with the file extension .csv, because that's how I would like it to be. Because temporary file is nice in that I don't need to clean up. R will knows that this is a temporary directory, and when the session ends, it will destroy it automatically. And now I need to save that. There's many functions that you can use to save CSV files, including the function room write, which takes a data frame, a file path where you want to save it, and also has a delimiter that in this case is going to be a comma. So that's how I would like to save the file. If I would like to inspect the file, I can use read lines with the argument file, and this is what the file would look like. As you can see, x and y, and then 1 and 2 are separated by commas, which is what you would expect from a CSV file, right? So now let's actually do something. Let's act on this function. So the output that I would like to get is from load file. Load file with the file argument with the file argument, right? So this file argument is a path, right? And the load file function has an argument that can take it, and then once I achieved basically reading. So what I would like this line to do is to read that CSV file that I wrote in the line before, and then the last thing I want to do is to use the second of the two most important expectations in the test as package, which is expect equal. So expect equal takes the output or basically an object that I want to, or two objects that I want to compare. In this case, out. So if the result of reading in that CSV file should be the same as the original data frame, right, that I got. So that's the expectation. What happens if I run the test? Well, it should fail, because that's the very first step in test-driven development. You write a failing test. Once it passes, it will confirm that the feature exists, but not yet, right? So I get an error that says invalid file. Why? Because that's the only thing that this function knows how to do. So I need to implement the behavior. And to implement that behavior, well, there may be more than one way, but one way is to first extract the extension. And for this, I'm going to use tools file extension. So once you pass a path to this function, to the function fileExt, it will extract that extension, and now I can use that extension. Say if that extension is identical to CSV, then what I would like this function to do is to return the result of reading. In this case, I'm going to be reading with vroom that file that was given, and the delimiter that I'm going to be using here is a comma, because this is a CSV file. So let's see if this cuts it, if this passes my tests. If it does, I'm done with this iteration. It does, right? It passes that that test. I also see that there is a kind of annoying message here that I could deal with later. Well, annoying. I mean, it's an informative message, but if I wanted to suppress it, there is things that I could do. But again, test-driven development. One premise is that when you write code, you write just enough code to pass those tests. You don't write more code than that. So it's kind of easy to know when you're done. That is when you finish passing your tests. So that's the implementation of CSV. So now let's do the same with TSV. Quick and dirty. It's fine here because the refactoring comes at the third stage, not now. So now let's do let's transform this test to check that this is a can read a TSV file. I think that's all I need to do, right? So it reads a TSV file. It takes a table. Stores it in a file that it has extension TSV, and then saves it there. So if I now do cat read lines file, yeah, this is a file separated by tabs. Makes sense. And then I can read the file, and then I can compare that the output is equal to the data frame that was originally given. And I'm intentionally separating these in 3 blocks. These are commonly called AAA. So the first A is arrange. That's the concept that comes from testing. The second one is act, and the third one is assert. Right. So typically you don't include those comments if you are, they're common, and structuring your test that way is common. So you don't really need those comments there, but I'll leave them there just to mention that. Just to mention that structure of tests. Let's run the test. This should fail because TSVs haven't been implemented yet, and now we move to tests. Oops. And let's implement it. So the way I can implement that is to extend this. If is a TSV as opposed to a CSV, then the delimiter has to be tab. So this should pass my test. Let's see if that worked. There you go, test passed. So now that I have the safety of the tests, I can be very aggressive in how I restructure the code. I can refactor it with, for example, switch, because the ifs switch. This is an example that is relevant for switch, because switch tests that a value, in this case, a variable, in this case, extension, holds a particular string. If that string matches CSV, then what I want to do is what I did here, right? And if it matches TSV, I want to do this other thing. And if so, with that I can remove this, and then if it is none of the two, then I want by default throw an error, right? So that is my new refactored implementation, and as you can see, I was very aggressive in the refactoring because I have the safety of those tests. The test passed, that's great, and maybe I could now work on removing that that message. This is a message, so let's see how I could do that. Let's do one more thing. Maybe let's extend this one here. Let's move it here to the end. So what I'm gonna do is throws no message. Throws no message. So what I want is that this call I mean, as is now, as you can see, if I call this function load file, I get this spec message here that I could suppress it, right? So what I can do is expect message. So I want to test that there is no message. To say that there is no message, you say that the message that you expect in the place where you would normally write a regular expression to match the message, you say NA, and that would give that would do the trick that we want. So now I'm testing that it draws no message, but because we haven't implemented the suppression of the message, we still have it, and therefore this test fails. So we have entered our first iteration, again, our first component of this iteration of test-driven development. So let's go ahead and implement that. So that was, what did we read there? CSV, yeah, CSV file. So we could suppress messages, I guess, suppress messages, and that would be very aggressive because it could remove every message. So instead what I'm going to do is another way of suppressing the message, which is call types. So if you do call types list, that will remove the message. So I will run the test to confirm that they pass now, and they do. I could implement it here, but that's illegal in the test-driven development approach. First, you have to implement it here, right? So I can now use the two things here in the same test for convenience, or in a different test. Let's do it in the same one. So here in this one test, we can do file underscore CSV, and we can use that here and here, and then we can do a TSV, and we write that TSV with a tab as a delimiter, and then we test that. Okay, so we should get now one failing expectation. So we implement that now by copying this little text here, pasting it there. So okay, that should do the trick. And test now pass. So now it's kind of nice that we have suppressed that message. And now if I can load this, if I read a file, CSV file, it just reads it. There is no more message there. Same for a TSV file. Okay, so with that, I've shown the implementation of test-driven development. The implementation of the function itself looks a little different than the one that you see in the book. Actually, my implementation is a little simpler. I can't be sure, but I suspect that it was a mistake in the book, unless I'm missing something. The implementation in the book has this argument name that is not used other than for the extension. So I suspect that that's a mistake. And that's also gives me the opportunity to discuss one benefit of test-driven development, which is this idea of, because you only write code that is required exclusively to pass the tests that you have set up for yourself, you never end up with an extra argument, for example, because if there is no, if you haven't tested for that argument would never be there, right? So it's a side effect. It's not the main purpose why you work with test-driven development, but it's a very nice side effect that you end up with functions that are testable, more or less error prone, and more maintainable, because there's a huge connection between maintainability and testability. So with that, I want to acknowledge that there's CJ's comment about that it might feel more natural to start from somewhere else other than where I started test-driven this development, but it's totally up to you. Test-driven development is just one tool for thinking really about what to implement, and then how you implement it kind of follows from there, from the goal that you set for yourself when you first write that failing test. How you go about that, it's totally up to you. Maybe through practice, you will notice that the way you write your tests and your code changes through time. It kind of strongly has an impact on how you write code. in a very positive way. So when it's applicable, that is when you know exactly what the function should do, I strongly recommend it. I look forward to the next meetup.